So starting on example 5 of our notes today. So we're writing the equations from a piecewise function graph. So we have 2 at this point. This is an absolute value function, if you remember from parent functions, and this is a horizontal line. So your horizontal line is going to go all the way through if we were to extend it to that positive 3. So this would be our x-intercept, right? And remember, horizontal lines are y equals whatever number it touches the y-axis. So that's going to be 3. Absolute values, remember our parent function is absolute value of x. If it moves to the right or the left, that's x minus h plus k. And hk is your vertex, just like a quadratic in vertex form, but absolute value bars are no squared. But otherwise, very, very similar. So our vertex is 0, 0. But this time our slope changed. It's 1 over 2, up 1 over 2, up 1 over 2. And the slope is what goes out here for our our absolute value function. And it's not a positive and negative necessarily. It's just the change at the rate that it's either going up as it's increasing. Is it fast or slow? So 1/2 is a slower increase because it's not going up super fast. It's much wider and it's going up 1 over 2, up 1 over 2, up 1 over 2. So that's going to go in the front. So we're going to 1/2 x, because 0, 0, no need to write since it doesn't exist. So if we write that in, we'll say g of x this time. And with g of x is y, so we're just going to say it's equal to 3. And then we have 1/2 x, absolute value of x. So 1/2 the absolute value of x. And now we need to set up our domains, because that's what makes piecewise part of piecewise, because these graphs don't go on for never and never in either direction. If we're looking at our 3, so our horizontal line, it's going from all the small values of x all the way up to -2. So -2, and x is less than, because it's going this direction with -3, -4, -5, less than -2. Not equal to, because that's an open circle. Our absolute value function starts at that -2 and then goes on forever to the right because we have that arrow on the right-hand side. So that means all the values of x are greater than -2. And that is a solid circle, so it's going to be an equal to. All right, our next one, we have an quadratic, absolute value, quadratic, because it's a parabola, but it's just cut off. I'm going to check and make sure that its rate of change is right. Yep, and then the next would be 5. So 1, 3, and then it should cross right here if it is a standard parent function of a quadratic. And in this case, it did. Its vertex just moved to the left. So it's -5, 0. When we're thinking about our vertex form for our quadratics, remember that's x minus h squared plus k. So very much like the absolute value, like I mentioned, except parentheses and squared. And then if there was a rate of change, that would be illustrated here in the front. So our HK is our vertex, and it's a -5, 1 or -5, 0. So we know this is a 0, so we don't even have to write it. But our H, since it's a -h and the number's a -5, it's going to be x plus 5 squared because it moved to the left. And that minus and negative give us a positive 5. So for our first function, it's here. And then we have another horizontal line, and it crosses through 4. So that's going to be just 4. So y equals 4, y equals. And if we write it in function notation for piecewise functions, we're going to have x plus 5 squared. And then we have 4. And then we have to set up our domains. So our quadratic is over here with an arrow. So it's in all the small values. And it comes all the way up to -4. So -4, our x values, that x is going to be less than -4. So -5, -6, -7, -8. And again, because if I go to -2, that's not my quadratic function anymore. So x is less than -4. It's also equal to, because that's a solid circle right there. Our horizontal line at 4, it's going to go on from -4 to all the positive values. So x is going to be bigger than -4. -3, -2, -1. 6 is bigger than -4. And you can actually, I'm not just saying that because I'm the teacher. I'm saying that because that's a way to check that you're in equality and that you're saying it right. So I mean, X values are bigger. X is bigger than -4. It is an open circle, so we're not going to color it in or put an equal to underneath it. And it does go on for all values larger than -4. All right, 2 examples done.